Good evening, everyone. Yeah. Good evening, everyone. Hope my voice is audible. We can start now. Hope my screen is also visible. Those who have joined today new, I will just give a brief intro about myself. I am Saravanan, PhD scholar and Prime Minister Research Fellow at Department of Civil Engineering, National Institute of Technology, Tiruchirappalli. So, just a small brief. I have done my bachelor's in civil engineering from Government College of Engineering, Bodi, and my master's from College of Engineering, Gimbi, and University in 2021 through GATE score. And I have joined in National Institute of Technology in 2021, and I have submitted my research proposal to the Government of India for the Prime Minister Research Fellowship Scheme. And from 2022 onwards, I am a Prime Minister Research Fellow. As a part of deliverables, I have to take 2 hours of class every year, every week. So this is the plastic waste management course I have associated with. This is like week 8, and we are going to discuss first 1 hour with the lectures that we have gone through. The same video PPTs as taught by Professor Dubey sir, and then next 1 hour we are going to discuss the old assignments of 2022 and 2021. Yeah. So go to the session. Yeah. So for first First week we have discussed about the plastic, how the plastic was made, what are the ingredients, what are the additives and types of plastics based on the recyclability numbers, and then the production techniques, different manufacturing techniques for plastics, and then uses of plastics in India and global we have seen. In the second week we have discussed about the plastic waste, the source of plastic waste and its statistics, and then in the third week, we have discussed about the plastic waste management rules in India, that is on 2016, and other global rules and regulation related to plastic waste. In the fourth week, we have discussed about the plastic ban for single-use plastics in India, and then other countries ban on plastic waste, and then major ban is the China's national SWAT policy and its on impacts on other countries' exports and imports. Then, in the fifth week, we have discussed about the impact of plastic waste on marine life, ecosystem, and human health. The sixth week, the plastic waste management practices, like what are the different techniques to manage the plastic waste from feedstock recycling to incineration and pyrolysis, and then what are the different methods to upscale the plastic, like plastic road, using plastics in the plastic roads. That and all we have discussed in the week 6. And in the seventh week, we have discussed about the possible green alternatives to plastics, like bioplastics, and what are the different ingredients instead of synthetic polymers, what can we do from the natural polymers, that we have discussed in the last week. And this week we are going to cover the final topic, that is plastic resource recovery, plastic and circular economy. This is the broad concept we are going to discuss. Mostly it will be a theory concept, like how the circular economy works and how the resource recovery can be done for the plastic waste. Yeah, moving on to the next slides. So this is the broad scheme of plastic product life cycle. I hope I have discussed about life cycle in the last session. Life cycle assessment is the analysis of a product or any manufacturing process from its production, I mean extraction line, to the end of life phase. That's what we are going to discuss, going to assess. That is its life cycle. So here, if you see, the raw material was acquired, that is extraction. Then in the production line, it was used to manufacture a monomer, that is the monomer processing. Then in the manufacturing, it will go to as a product, it will used as a packaging material, and then it will be distributed to the uh, consumers. Then consumers will use, and then they will reuse if possible, and then it will go to disposal point. The major disposal points, it may end up in the landfills, or we can use this disposable plastic for energy recovery. Some part of plastic will go in the recycling line. If it attains the recycling line, it may be going used for again monomer processing or manufacturing of plastic resins. Again, it will be introduced into the production line. So this concept we will call as circular economy. We are closing the loop. Yeah, we are closing the loop of linear economy, and now creating the line to again end up in the manufacturing process. So whatever disposed, that will enter into the manufacture line. So we have closed the loop, that is called the circular economy, that we are going to discuss in this session. This is called the circular economy. So sustainability is different from circular economy. Sustainability, that we have discussed in the last week. So mostly some people will call something, if it is more durable, then it is sustainable, but it's not the real case. Most, if it is more durable, then the design is fine, but uh, after the end of its use phase, it will anyway end up in the disposal unit. So it should have a property to be introduced in the recycle line or a manufacture line, then only it is called sustainable. Yeah. So circular economy will eliminate waste and pollution by circulating products and materials at its highest value and regenerate nature. So we can call the three pillars of circular sustainability as social, economic, and environment. Initially, we will any product design will consider only the economic point of view and the social point of view, how the people will use and what are the benefit we will get. But now we are introducing a new pillar called environment, how it will impact the environment, the production and the use phase of the product. That also we have to consider while designing any product or process. So here comes the sustainability. The third pillar of sustainability plays a major role. So this is the waste management hierarchy. The width of the line indicates the the preference, most preferred, and the least one is the final one. That's the least preferred waste management option. So first we can see the source reduction. It can take example a paper. If I am using a paper to write my notes, then that is yeah. So if you take paper as example, after I write one-sided paper, then I am using the back side for again writing the writing purpose. So that is called the reuse. Reusing reusing the paper again for writing purpose. Then recycle. So if the paper got over in the both sides, then I should not throw that in the dustbin. I may try to recycle I mean that paper into another product like for a packaging or for manufacturing of any other cardboard boxes like that. If I am using the same used paper for any other material, if you use on its own chemical composition or own structure, then it's called reuse purpose. If I am altering its compound and then you using in the manufacturing of some other we will come to the objectives of circular economy, sorry. Yeah, in the upcoming slides, we will go to discuss. Yeah. So if I'm altering the structure of a product and then reusing again, then it is called recycling. So that's the difference between reuse and recycle. If I am using the paper as it is, then it's called reuse. If I am using the paper in a modified form, then it's called recycling. Recycling for production of some other materials. Then if I after reusing into a recycled into a cardboard box, after the use of the cardboard box, what can I do? I should not dispose the cardboard box in the dustbin. Again, I will try to extract some other material or energy out of it. So whatever the material possible, I will first extract. Then no possibility for material extraction. Then I will try to extract energy out of the cardboard box. So that is called incineration or waste to energy process. Finally, if nothing is possible, only the ash or any inert is present or no not, like non-recoverable items should reach landfill as a final disposable option. So these are all the waste management hierarchy. We will first try to reduce the use of paper. How can I reduce? I can use some digital board to write, or I can use some reusable board, white marker board for writing. That kind of thing will reduce the use of paper. So that is called source reduction. I will try to reduce the source. If there is a possibility of waste generated, then I will try to reuse. If I can't reuse, then I will recycle. Then I will try to recover the material, and then I will try to recover the energy. If nothing is possible, I will dispose in a scientific way, that is called landfilling. But in the actual scenario, it's in the vice versa phase. Like landfilling is happening more and the source reduction is happening less. We try to invert the triangle, and we have to make source reduction as the most preferred option. So the plastic waste recycling, this is the plastic waste recycling value chain. Once the consumer use the product, then they will first produce the waste, that is the waste producers. Then the waste will be handled by the municipality. There may be some loss of waste in the environment and in the river or water streams. So before reaching the collection stream, it may end up into the environment. That is called a loss in the streams and environment. After reaching the collection point of the municipalities, then the waste handlers will shift it to recycling and sorting facility. After sorting, some rejects may come like metals and some other waste will be the rejects. And after recycling, we will add that into the production line. The producer will add some virgin plastic added to it, and by proper design will get a new plastic material. That is plastic consuming company will use to manufacture a new plastic material that will be again used by the consumer. So this is called a plastic value chain. The linear chain we are changing to circular chain. That's called circular economy. Yeah. So in the production line, there may be some wastage. In the recycling line, there may be some rejects. In the waste handling side, there may be combustibles that may go to incineration plant, and in the consumer itself there may be a loss into the environment before the collection state. So this is the plastic waste recycling value chain. This is another representation for circular economy. Once the material was extracted, then it will be designed and acquired, like acquisition of material and components by engineering methods and tools, quality control, distribution of the product. Yes. So this is called the upcycling, upstream. Once the product is designed, here comes the downstream. Here in the downstream, the material was used or reused, and after the end of use, it may be recovered as a mass or energy, and quality control, it will be redistributed into the material cycle. So that is called downstream. So that first upstream is the manufacturing process, downstream is the use and the disposal phase. After use and disposal phase, it should not enter into the disposal line. Instead of that, it at the end of life management, like recycling or energy recovery, this type of option is called a circular economy. Yeah. So here we are converting the downstream to upstream. That's called the upcycling phase. Yeah. Here comes the pillars of sustainability. That is social, economic, environment, and we have to think about technical also. Technical in the sense, if anything, if I am trying to manufacture a pencil, if the pencil should be socially acceptable, it should not harm the environment, and it should be economical. Like I can buy it within a cheaper amount. But technically, the design or a process that I have proposed should be viable or feasible to manufacture. That also plays a major role, technical feasibility. So we have to add that as a fourth pillar. These are all pillars of sustainability. Yeah. So here, if we are analyzing only social, then it is called a social life cycle assessment. If you are assessing only economic, then it's simply a cost benefit analysis or input output analysis. You can refer my papers in Google, cost benefit analysis. I am working on landfill mining, so I did a cost benefit analysis on landfill mining process. So that also you can refer input output analysis, life cycle costing. So how much cost incurred in the project, how much benefit we will get, and we can find the net present value. That is called the cost benefit analysis. So if you are analyzing only the environment factor, then we can do, as I mentioned in the last lecture, LCA, life cycle assessment, or environment impact assessment. So environment impact assessment is a local analysis, how this process may affect only this local chapter we can analyze. But life cycle assessment is a global perspective. How much emission into the atmosphere, how much emission into the waterways. This and all life cycle assessment. So combining two parameters will give you some other analysis. If we are going to check only the technical feasibility, then you can use some green chemistry matrices, some technical performance matrices, TPM, manufacturing and engineering matrices. So if you are combining both environment and economic, then it is called eco-efficiency analysis, eco-friendly extended IOA, EE and IOA. So if you are using all the three, like economic, environment and technical, then it is called eco design. So the design itself incorporated with the economic and environment. That is called a green design and the eco design. It will be having all the three, economic, environment and the technical. Yeah. One second. Yeah. Here comes all the three. Sorry, all the four. Social, environment, and economic. That will be the sustainable assessment methodology and life cycle sustainability analysis. As I mentioned, these three will include into the sustainability. If all the four combine, then it is the complex value optimization for resource recovery. So we are going to discuss all the four
Please say
strategies.
again. Excuse me, would you please go to previous slide?
Yeah, ma'am.
So environment plus economic, you
Yeah,
told that is EEIOA,
IOA. Yeah,
right? And if these three combine, economic, environment, and social,
environment and social.
that is
No,
it
no.
sustainability?
Fine. That is called environment, economic, and social. Three. I can look into it. Like all the three has here. Like economic comes here, and social will be there, and the environment also there. Except technical. Then all the three pillars will be in sustainability.
Yes, that thing I want.
Uh, you got it, ma'am?
Yes, yes, I got.
Yeah, yeah. So as I mentioned here, so sustainability has three pillars: social, economic, and environment. That's what we have discussed. So if all the three combine, then it is called sustainability assessment methodology, life cycle sustainability analysis (LSCA). Yeah. So we are going to discuss about the economic strategies, environmental strategies, and social strategies. Finally, the technical strategies for recovery and recycling of plastic solid waste. So all these are theories, vague theories, but I will try to define somewhat in important points to discuss. Like in economic strategy, first we have to reduce the cost. So everything we will discuss about price or cost. So like if you reduce the energy, lower energy requirements and high demand for materials in manufacturing, and then the cost of alternative acceptable forms, like if you are going with the bioplastic or some other natural polymers, then the cost of material acquisition or raw material acquisition should be lesser. That are all economic strategies we have to enhance for recycling. Then the price of virgin polymer compared to recycled polymer, how it will affect, how it can enter into the supply chain. These are all economic point of view. Yeah. So if you are going with the environmental strategies, enforcement of, yeah, environment itself, we can think about the producer responsibility, extended producer responsibility (EPR), and we discussed in the second lecture itself. It's the responsibility of the producer to collect the disposed waste produced by him. So his responsibility not ends in the gate of the company. It will also extend up to the consumer's home and its disposable point. He have to collect and reuse in it in its own manufacture line. That's called extended producer responsibility. Or he have to pay the government to collect and manage the waste produced by his company. That's not by his company, his product. So these are all coming under producers extended producer responsibility. Enforcement should be there in the regulation itself and encourage collection of plastic waste. Then enforcement of national wide law on plastic waste recycling. Then selective collection of by waste pickers. Like these are all not what we call legal or somewhat we can say waste pickers are like they won't come into the government or any other legal sectors. They are simply a collectors that are informal waste sectors we can call informal waste pickers. They will take part in most of this collection of recyclable items. And then enforcement of environmental awareness program, enforcement of waste segregation at the household level itself, then creation of quality standards and certification scheme for plastic recyclers. These are all environmental point of view. We have to discuss about only recycling point. Yeah. So household level awareness program also plays in the environmental strategy. Then if you come to the market strategy, then again it will be related with the cost like formation of polymer recycling streams and markets. So whenever we are acquiring some recyclable item, if we are can we convert then that into a new product and we can sell it in the market or not, that is another question mark. So I am working on some plastic from the landfill, so I am trying to recycle into a new product. So now I am going to check whether some market available is there or not for the material made from recycled polymers. It's not a virgin plastic. So this material was made from some recycled polymer. So whether there is any market availability, whether it is I mean, it may be strong, but the people's mentality should be different for recycled items. So that and all we have to focus on. That's what formation of polymer recycling streams and end streams in markets. Then closer engagement of recyclers to collect and we have to made a streamline to collaborate with all the recyclers to collect waste that is created, and then recycle to deal directly with the municipalities. That is another market strategy. We have to link this informal sectors with the government to close the loop. Then existence of market systems, then transitional cooperation on waste plastic recycling. Yeah. Then social strategies, that are all comes under the consumers behavior change. Like if you give incentives for using the plastic recycling product made from plastic recycled item, then you will get a motivation to buy the material that is from recycled items. So we have to give some incentive schemes to motivate plastic recycling, and then efficiency of the municipality, private based contractors or informal sectors to collect the for waste collection. Then introduction of plastic waste segregation at the household level for recycling purpose, increasing consumers awareness, that is a major thing. Awareness, increasing the awareness and behavioral change. Then by this can be achieved only through education of the households and communities on the relevance of informal waste collection in the supply chain. So these are all comes under social strategies for behavioral change to enhance the recycling and recovery of plastic solid waste. Yeah. Then comes in this technical strategies, whether it is technically feasible or not. To improve, it is we have to attain an improvement in the recycling technologies. Whatever the technologies available is only for a single type of plastics. If you collect only PET bottles, then they will be easily recycled. If you collect only polypropylene PP or separate PS, they have a technology to recycle. But if the waste is mixed or a heterogeneous collection of plastic waste, then whether my technology is feasible to make a product or not. So we have to have an improvement in the recycling technologies, improvement in the size reduction technologies, improvement in the sorting technology. If I give you a mixture of plastic, so I thought whatever the plastic waste I have collected from the landfill is LDPE because it's carry bag. But after FTAR analysis and composition analysis, I came to know these are all not only LDPE. It's having some HDPE and HM plastic and some polystyrene plastics mixed with the carry bags. So this type of normal manual sorting is not enough. Yeah, normal manual sorting is not enough for segregating this type of mixed plastic. So we need an improvement in the sorting technology, and then there should be a design, proper design for product for recyclability. Whatever the product, first product whatever we are making with the virgin plastic, that should have a feasibility to recycle. So we should not mix different type of plastic that we are going to discuss in the upcoming slides. We should not mix different type of plastics to make a single product, that will be difficult to recycle. So if I made one shampoo bottle made up of only PET, then it is easy to recycle. This type of design should be there in the manufacture line. Then in the fifth point, ensuring material applicability in the manufacturing process. Yeah. Again, the technical matrices, what are the things we need to consider? These are all matrices. What is the calculation we have to make? That is reusability. How much amount of material retain in its functionality. That is called reusability. As I said, in its original form, it should be reusable. Then only, sir, it is possible to recycle plastic with different additives. Yeah, that is the problem, sir. So I tried some chemical. I'm explaining my project. So I tried to extract the polymer of a plastic product using chemical method. So I have used some solvent and anti-solvent to extract the polymer. So after the extraction of the polymer, in the solvent, I got some color or pigment additives and some of the what I can say, like enhances the strength enhances as additives. This type of material I can infer from the FTAR peaks. So if I am the product is not having this type of complex structure, it will be easy to recycle. Or else we have to have research on the techniques that should be suitable for plastic with more additives or different types of mixed plastics. So as of now, we don't have a system to recycle mixed plastics. Yeah. So if you give only PET bottles to the government or recyclers, they are ready to take and work on it. That's the, or they have a complex system to sort it out, manual or separate technologies to sort. Like as I explained in the waste management, plastic waste management session, triboelectric technology, density separation, and then flotation technique. There are all different techniques to separate the type of plastic and then recycle it. Yeah, this is also feasible. But as considering the additives, it's very difficult. It's molecular level work we have to do. Yeah, better to avoid additives. We have to design, that's called a cleaner production or eco design, we will call green design. These are all the things reduce the usage of extra additional materials to but in its own form it should be perform the denoted function. Yeah, hope I have answered your question. Now coming to the technical matrices, first is reusability. As I mentioned, reusable, it's in its original form it should be functional, then it's reusable, remanufacturable, potential to restore a component or a product and to refurbish or repair or replacement. Then mass recyclability is amount of material collected on weight basis for recycling. But mass recyclability is very different from technical recyclability. As I mentioned, technical recyclability is only one material collected for component made up of, yeah, one second, yeah, component made up of only one material collected for recycling is technically recyclable. But if you collect 1 ton of plastic waste daily, and I say like daily I am recycling 1 ton, it's not the case. I am collecting 1 ton of PET bottles separately, that is called technically recyclable, then it is giving high quality recycled material. Yeah, that's the point here, technical recyclability and mass recyclability. Yes. Then mass recoverability, recover in the sense it will be captured up after the end of use. Then energy recoverability, whatever the energy embedded in the material or any material, plastic or a product, that can be recovered after its use by waste to energy plant or in any incineration plant in the form of heat and electricity, that is called energy recoverability. Then technical recoverability is how much weight share that can be extracted for use same but in terms of a single product. Yeah. Then technical advancement, improve the efficiency of technology using processing step of resource recovery systems. Yeah, here comes the definition of circular economy. A circular economy, as I'm just reading the exact definition, is a circular economy is an alternative to traditional linear economy. So linear economy, as you know, uh, take make, dispose, this is called linear economy. Whatever I am taking from the mother earth, I am extracting something and then making into a product, that is make, and then after use I am disposing, this is called take, make, dispose, use and dispose, this is called linear economy. But where can I am getting some material, extracting some material from the mother earth and I am disposing into the again into the mother earth, then where at one stage I will, there will be a demand for, there will be a rising demand for raw material extraction, and there will be again rising demand for land or any method to dispose the generated waste. So here comes the circular economy. uh, I can use the waste generated as a resource or as a raw material for manufacturing, so I am closing the loop. The straight line I will try to, okay, I can't write here. Okay, let it be. So the straight line I am changing into a circular path, that is called a circular economy. Yeah, that is make, use, dispose, in which we keep resources in the long, as long as possible, extract the maximum value. So whatever the possible options I can, after using one-sided paper I am disposing, means I am not using the paper to its maximum level. So backside if I am writing and then I am extracting some energy and then I am extracting some material out of it, then only I have used the product to its maximum extent. We are not using any product to its maximum possible extent. That's what the problem with the waste generation, lots increased quantity of waste generation. Yeah, to recover and regenerate product and material at the end of each service life. Once it's become waste, then we have to extract its maximum value by again incorporating into the manufacture line. That's the definition for circular economy. It's an alternative for linear economy. So how can we achieve this? By design. By designing a constant flow around the circular loop without leakaging into the natural environment. Whatever the waste that is disposed in the environment, that is leaking into the natural environment, that we have to avoid by closing the loop. Yeah. So here comes, yeah. Once the raw material is extracted, that's the red line, from water, energy, resources like trees cutting, like crude oil, that and all resources we are using the extracting the raw material, and then yeah. So lots of Chinese today. Thank you for that. Yeah. So raw material we are extracting and then we are designing. We are using the production line. We are distributing the product. We are consuming and the consumers will consume the product, use, reuse, repair, whatever the maximum action we can do. Then we are disposing. Then the collection stream will collect and then they will try to recycle. Here some residual waste will come. Yeah. So again recycle into the design, that's called circular economy. But you can think like other countries like developed countries like US and UK generating more job opportunities in this circular economy field. So we should not think waste as a waste, we can think waste as a biomass, or we can think waste as a resource for our development. So there comes the circular economy concept. So here you can see some of the videos related to circular economy in YouTube, how it plays, how it's. So here in this video, he will take some vegetables from the fridge and how it will get into the plastic packaging of the vegetable. It will go to the disposal point and will be collected and recycled to manufacture again the food cover packages. Again, it will come to the fridge. This is called the closed loop and circular economy concept. Yeah. So the principle behind the first principle is preserve and enhance the natural capital by controlling the finite stocks. Whatever the stock we are having, that is energy, that is renewable energies, finite materials, regenerate, substitute materials, virtualize, restore, renewable flow management, stock management. These are all first principles we have to think for raw material extraction. Then in the second principle line, we can think about the optimize resource yield by circulating the product, whatever the product that is going into the biosphere. And I mean, here is the manufacturing site, here is the collection and disposal site, user and collection consumers. After collection, whatever its disposal point, like it can be extracted by feedstock, it can be going for biogas plant, it can be ended up in the biosphere, and then form, it may end up in the food production and then reaching again the manufacturing line. In the third principle, foster system effectiveness by revealing and designing out negative externalities. Here we are minimizing the system leakage and negative externalities. So here we have to try to minimize the leakage and whatever the disposed waste that we have to incorporate in the manufacture line. Here is the leakage. Whatever the fossil fuels we are acquiring in the like what we have discussed as of now is simple circular economy concept. But this slide discuss about the circular economy solution in plastic sector. So plastic will be manufactured from fossil fuel base. So whatever the fossil fuel is not a renewable resource. Some point of time it may be like it's over, it will be over, then we have to rely on some other source for raw material. So fossil fuel is not a renewable resource. We are taking and we are designing plastic products and production and products, then it will be reaching the consumers. The consumers will use, and there may be some leakage without entering into the waste management stream, and it may be energy recovery into the production line. Here we have to minimize the leakage, and then it will be recycled. These are all recycling and reuse purpose into the production line. Yeah. This is again plastics and circular economy, like whatever the process fossil fuels we are taking, or some of the plastics are manufactured using bio-based materials also. So producing, using, and then collection, disposal. 66% of the used plastics are disposed. Only 37 is recycled into the 30. Yeah, 34 is recycled into the production line again. Here the circle you can see, width of the circle. Whatever the 100% fossil fuel we are extracting, out of which after the use, the 100% is in the line, but 66% will end up in the disposal point, and only 34 reaching the production line again. Yeah, that's the number. So plastics are key enablers of circular economy, improving resource efficiency and sustainability along with the value chain. So plastics have a positive impact on the range of circularity. So we can compared to other material, plastics have a positive impact on circular economy. Like different process we can adopt, like material efficiency, energy efficiency, CO2 reduction, because using virgin material will again emit greenhouse gases. So this type of recycled material in the production line will reduce the CO2 emission, and then recyclability, durability, biodegradability, this and all will increase. Properties of plastic will enhance the circularity. Biodegradability in the sense I mean bioplastics I am talking about. Yeah. The circular economy solutions in plastic sector the same. Produce plastics from alternative feedstocks, use plastics as a resource, and then redesign plastic manufacturing process, improve longevity. I mean, whatever the product in the work phase, the life should be more. Then it will be entering into the recycling or disposable point. So redesign to improve the longevity. Then increase collaboration between the business and the consumers. Then develop robust information platform. So these are the objectives of circular economy. I think somebody asked about the objectives of circular economy. Here you can see this is the objectives of circular economy. First is design out the waste. There should be no waste. Design out the waste and pollution from the system. Then keep product and material in use. Then regenerate natural systems. Redefine growth. Gradually decoupling economic activity from consumption. Transition to renewable resources, build economics, natural and social capitals. Yeah, these are all the objectives of circular economy. Another version of sustainability. So here comes the importance of circular economy. It will reduce waste as usual and drives greater resource productivity, more competitive economy. It will position the world to better address emerging resources, help to reduce the environment impact. In our point of view, it should reduce the environment impact on production as well as the consumption line. Yeah, here comes the case study of Unilever. Unilever, as you know, all the major this is one of the not one of the top leading major producer of plastics in the world. So they have taken some steps towards the circular economy. So that we are going to discuss in the next 15 slides. So Unilever, they have a different targets to achieve, like rethinking how to design their products, driving systems change in circular thinking at industry level itself, then working with governments to create an environment that enables the creation of circular economy. Yeah. Then working with the consumers again on different disposable methods and exploring radical and innovative approaches. So here, how to rethink whatever we have discussed earlier. Now we are going to discuss in detail how to rethink in design by reducing the use of materials. As I mentioned, additives should not be there. That will enhance the recyclability. Some mixture of plastic should not be there. Again, that will increase the recyclability property. Using more recycled content in the plastic manufacturing. Ensuring the packaging is recyclable or compostable. So whatever the product they are giving, that should have a low use of packaging, low material use in the packaging sector. Yeah. Then again it comes whatever the things we have discussed, we are going to discuss in detail. Reducing the use of material, like whichever lighter, stronger, and better material. Quantity should be less, but it should be strong. It will have a give us good strength, and which is the better material which have low environmental impact. That optimization should be done in material each time they redesign their packaging and develop contracted or composed version of their product. So once they have designed, think about some cosmetics by Unilever, and while they are thinking of a redesign, the product should be compact and compressed version that should be having lower environment impact. Yeah. Then some significant investment should be done by the government or by the company to enhance the product quality. I mean recyclability, and then collaborating with the suppliers, academic startups to develop new technologies. As we have mentioned, we are all academics. I think most of the people are from academics. So the company should collaborate with the suppliers and academics, and they have to give incentives for research that he is working on this type of plastic waste management and designing different technologies for managing the plastic waste or to produce less plastic waste. Yeah. Again the repeated slides. Here second point, using more recycled material in the production line. How to first capture the recycled material, then how to bring that in the manufacturing line. So they want to these are all from Unilever's case study reports. So they want to use far more in the future and recapture their own packaging. That's more important, recapture their own packaging material. But factors such as availability of high quality waste material, because if it is mixture, that is the problem. Yeah, that are all factors affecting the recyclability. Legislation on food contact, because food contact is another important. The whatever the plastic we are recycling, that should be fully sterilized, and it should have the it should need to improve the confidence on people for food and safety issues, because whatever you are recycling, that may come from some waste, bulk waste, so that should be fully sterilized. That should give the people a confidence that okay, it's good with the food and safety use. Because again, if I am using recycled plastic for packaging some food material, then it should not create any health issues. Yeah. For food contact, it is possible to be used plastic. Yeah, in that video, as I mentioned, whatever the plastic packaging he used for food packaging, that will again come into the food packaging line. Once it's having certification of fully sterilized and food safety certification, then we can use it for food food contact. No problem, there is no issue with that, but it should be ensured, that's the thing. Certifications are there for using these. No, we have to ensure. It's not like we should not use. We can ensure before using the recycled plastic for food packaging. Yeah. Whatever we are using now, we can't say that is a virgin material. That may come from recycled plastics. Hope it's clear. Then in the third point, ensuring the plastic packaging in recyclable or compostable. That's another important step taken by Unilever. In 2017, they have made a commitment to ensure we have to check in the labs. Then we can use it. Yeah, maybe. That's the production. That's a part of the production team. Yeah, that's possible. Okay, so in 2017, they have a commitment to ensure 100% of the plastic packaging uh, will be designed by fully reusable, recyclable, and compostable by 2025. Yeah, that's the commitment they have made. And then they in Chile, for example, they moved from non-recyclable folding cartons to across three detergent brands. So these are all known detergent brands by Unilever in Chile. So they are made with 100% polyethylene HDPE bags, which are recyclable, which saves 1,634 tons a year. So as I mentioned, polyethylene comes in the first, PET comes in the first in recyclability. HDPE will be the third. Like that, that is a recyclability number we discussed in the first class itself. So if it is 100% polyethylene, then it is easy to recycle. They have found a way to reuse plant-based materials for tea bags derived from renewable sources such as cornstarch. As we discussed in the last class, some alternatives, that is green alternatives for plastic packaging. Like that, for tea bag itself, some plant-based packaging systems like cornstarch they can use. And then movement to the circular economy approach for plastics need more circular thinking. You can look into some Ellen MacArthur's foundation. Yeah, collaborating with the Ellen MacArthur Foundation and the new plastic economy initiatives. These are all reports available in the website. You can go through. I have given the link in the reading material section. Please go through Ellen MacArthur Foundation and new plastic economy initiatives that we are going to discuss in the upcoming slides. By committing to publish the full palette of plastic material that they use in the packaging by 2020. Yeah, I think we have some questions. Can we use cornstarch? Means it's natural. Yeah, it's natural. It's like natural. As we discussed, bioplastics are from two categories. One is how the material is made. Second one is how about its degradability. So cornstarch is made from bio-based material and it is degradable. So it's fully degradable bio-based bioplastics. Yeah, it's correct. So we can use that as a natural bioplastic. It's degradable, biodegradable. Yeah. Can we say the better product design helps in improve plastic recycling? Yes, must. That's correct. Um, yeah, by better product design, it will surely helps to recycle the improve the plastic recycling. I think this question is asked in the assignment. Yeah. Okay. Where we are? Yeah. So this driving systematic change in the circular thinking at the industrial level by creating a global plastic protocol, because it should not be locally reliable. It should be a global perspective on plastic protocols to help the industries to collect the plastic waste by the government, and focusing on the three themes of recycling, reuse and recyclability in the product design itself, and then working with others in the plastic packaging. So every stakeholder should be there on the board, from consumers, plastic producers, rat pickers are one of the stakeholders in waste management scheme. Government should be there, academics, those who are working on plastic waste management and plastic design, these are all stakeholders important for circular economy concepts. So while thinking and designing itself, all the stakeholders should be there on the board. Yeah. So and then developing a market for post-consumer recycled products. After making some product out of recycled material, whether it should be marketable, that is the major issue as I mentioned. So greater manufacturer demand for post-consumed consumer recycled material will produce an increasing attractive business. Yeah. Then partnering with industries, like in 2016 Unilever joined with the CFlex. CFlex is a initiative of 60 European countries, organization and association across the entire value chain of flexible packaging. So this is a CFlex is a value chain for flexible packaging with 60 European companies. By 2020, it aims to develop robust design on circular economy. By 2025, it aims to develop a collection, sorting, and reprocessing infrastructure for post-consumer flexible packaging across Europe. Yeah. So these are all the deadline for thinking circular economy. Thinking circular. Yeah. So working with the government, carefully considering the system with the national government to develop the waste infrastructure, and then by thinking outside the control, limited investment in the waste industry. That is another major problem from the government side. We have to invest more on waste management along with the companies and industries to manage the plastic pollution. They continue to work with the government to develop policies and frameworks. Here comes the extended producer responsibility schemes. There can be any incentives, or there have to be a collected pool of money from the company to use for plastic waste management. This we are going to see in the Ontario case study in the upcoming slides. So they are collecting the money from the producers, and the government is using for waste management. Again, working with the consumers. Now we have discussed about working with the,
Excuse me,
yeah,
excuse me. You told about Cflex. So is there any full form?
CFlex.
Yes,
Yeah, that I
Flex.
have to check once. 1 second. Uh, 1 second.
Circular economic
Yeah,
flexible
circular
payment.
economy for flexible packaging.
Okay.
Circular economy for flexible packaging. That's CE Flex. Yeah, thank you. So working with the consumers. Again, here comes the incentives. Incentivating behavioral change for the consumers is a big part in inspiring lifelong recycling habits. So consumers are offered with the discount benefits to encourage them to bring their waste packaging to the government recycling points. Once the people are attracted with the like, we can attract the people with money for recycling. So this is again a behavioral change. We can give a long life recycling habits for the people by giving some incentives. Again, working with the NGOs to give some awareness program to the public. Yeah. Exploring radical and innovative approaches, new business models and innovations, unlocking the economic prices for business. These are all like business models and innovations created to uh, both in design as well as in the waste management point of view. This is a rethink, like instead of linear economy, take, make, dispose to circular thinking. Yeah. So again, here is the extended producer responsibility as I mentioned. So here some design and manufacture from the virgin plastic consumers are using and then discarding. So after discarding, here the company role may end at the gate. I mean to the cradle to the gate. If it ends, then it's called a cradle to gate approach. Then but the company should go through this disposable point, and it should be sponsoring for collection and sorting, processing the waste, again it bring to the production line. And this pink line will called the producers pay for end of life cost. That's called extended producer. The producer's responsibility we are extending from the gate up to the again to the production line. That's called extended producer's responsibility. So in the after disposal, collection, sorting and reprocessing again into the manufacture line, the producers should contribute. That's called EPR scheme. Yeah. This is again value chain for recycling. Waste will be collected, sorting, recycling, secondary raw material. Secondary raw material will again go to the production line, again consumer waste. That's the scheme. So here comes the statistics. So recycling rates of various drink containers. So first comes the consumers plastic drink bottles. Plastic drink bottles like water bottles or some other like soft drink bottles with plastic cartons. That and all made that and all 74%. Then which is with the glass drink bottle 70% recyclability. Then aluminum drink cans 70% recyclability. Then steel drink can 70%. Again, most of this plastic and glass steel will have more than 70. But this cartoons you can see like some fruity cans, like tetra packs we can call. These are all having less recyclability, up to 37% only, because it's having some straw made up of different plastic, and this box is made up of multi-layered plastic. That and all the problem with the recyclability as I mentioned. But this the plastic waste, plastic cans are made up of single type of plastic, glass is made up of single type, aluminum can single type, then steel can single type. But these cartons are multi-layered plastics, having one aluminum foil, thin foil inside, and then one LDP liner, and then above that one printed material. Above that again some advertising like printed, I mean metallized papers will be there. So this type of multi-layered packaging made this cartons less recyclable of about 37%. Yeah. So here comes the CO2 emission savings yearly of about, while recycling plastics we can avoid the CO2 emissions of 14 million tons. So think about 14 million tons of CO2 emission. We can convert it into any terms. So CO2 in the terms of greenhouse gas emission, how much global warming we can control. So all the environmental impact we can measure in terms of CO2 emission. That's called environmental impact assessment. So by analyzing the greenhouse gas emission of 2020 and 2025, we have avoided a lot of greenhouse gases by recycling. So here first you can see, first is the direct greenhouse gas emission by the product: collection, sorting, transport, recycling. So while recycling we have to collect, right? We have to sort the material. For that we have to use some water, we have to use some energy, we have to use some vehicles. There comes again CO2 emissions. So this type of CO2 emission will add positive side, 0 to 5 it have added metric million tons of CO2. But the direct landfill emissions all will add first point. But this negative will be from substitution of virgin by recycling plastic material. Again, whatever the recycled material we are collecting, that we are using as a substitute material for virgin plastic. So here it's a avoided CO2 emission. Then blue color indicates energy recovery. Some part of recycled material will go for energy recovery in waste to energy plant. So that will contribute some type of avoided GHG emission. So that's in the negative line. So if we add up both, it will be in the negative side only. So minus 7.9 tons of metric million tons of CO2 emission we have avoided. That's in 2020 case. But in the same in 2025, the plastic collected and this is all for recycling. How much collected, sorted, transport will add more, but in the same it will add more avoided CHG. So comparatively, we have avoided a lot of CO2 emission. Like if you see 14 million tons of CO2 emission we have avoided yearly by recycling. So this we have calculated through net emission. Yeah. So these are the core ideas behind circular economy. We can frame a design guidelines. We can improve the recyclability. We can harmonize the collection system. We can improve the quality of mechanical recycling. Create a pull effect. Create a pull effect. Yeah. How to collect from the people. That's called a pull effect. So here, as I mentioned, This plastic bottle is made up of only HDPE. So better product design makes plastic recycling easier. So that's the first theme line. Better product design makes plastic recycling easier. So saving 77 to 120 euros of each ton. So think about the amount. One euro if it is 80 rupees or something. So 100 rupees if you take 120 means 1000. I mean 12,000 rupees per ton we are saving in plastic waste collection. So this itself a big impact on the environment and the economic point of view. So if you are better design in the product, then we can save lots of money. So this is again a vision for Europe's new plastic economy. As I mentioned, the 60 European companies on waste management, they have created a policy that new plastic economy, and with Unilever with the MacArthur Foundation also, they have created this new plastic economy. So yes, smarter initiative on sustainable plastic industry brings growth and job to the Europe. So in 2030, all plastic pack. Yes, I got a question. There is objective circular economy that to reduce in sir, I can't answer the assignment questions. I think you are asking the assignment questions. You can go through the lecture material. Thank you. Yeah, it's okay. By 2030, all plastic packaging material on the European Union market is either reusable or be recycled in a cost-effective manner. So changes should be made in the production and design. Again, the same repeated concept. 2030 sorting and recycling capacity has increased full force since 2015, and the creation of 2 lakhs of new jobs spread all across the Europe. Again, this is a notable point. New jobs in waste sectors, waste recycling sectors. That is a important takeaway. Yeah. So more plastic recycling, cut down the CO2 emission, and reduce the dependency on imported fossil fuels. So they won't rely on other countries for fossil fuel import. They can work on their recycled product itself as a raw material. So again, it's more sustainable way of processing end of life plastics. Then prevent microplastics from reaching the sea. This is environmental impact. Halt the flow of plastic into the ocean. Remedial actions, and more product incorporate some recycled content in the manufacture line. More incorporation of recycled content. Yeah. So this is the key theme of new plastic economy. Eliminate, innovate, circulate. So eliminate the problem and unnecessary plastic packaging. That's important thing. This is the first waste hierarchy as I mentioned. Source reduction. We should reduce the source at the creation level itself. We should not create any waste. So unnecessary plastic packaging, if it removed, so you don't create any plastic. Whenever we receive any product from Amazon or Flipkart, first we will throw the packaging item in the dustbin. So if we don't have any packaging, then we don't have any waste. So eliminate the waste. That's the first point. Sorry. So eliminate. Second one is innovate. Innovate to ensure 100% of plastic packaging can be easily, safely reused, recycled and compostable packaging material. That is innovation. Then by 2025, that is the agenda. Then circulate. Circulate the plastic produced by the significant increasing the amount of plastic which is false. Please don't discuss the assignment answers here, please. Yeah, thank you. Okay, I'll continue. Sorry for that. So eliminate, innovate, and circulate. We are eliminating the unnecessary packaging, and whatever the packaging material is there, that should be recyclable or it should be compostable by 2025. And whatever the waste produced, that should be reused or recycled in the new packaging products. Yeah. Here comes the UK Plastic Pact. So that is the agenda they are having for UK. So the target by 2025 should be 100% plastic packaging will be reusable, recyclable and compostable. 70% of plastic packaging will be effectively recycled or composted, and 30% of average recycled content in the plastic manufacturing material. These are all the agenda. So by 2025, that is by next year, their aim is to make all the packaging material is recyclable. That is 100% recyclable. Then 70% of the material used in the packaging material will be recycled, should be effectively recycled, and 30% will be of the packaging material made from recycled content. Yeah. So that you can identify the difference, I guess. Yeah. Then zero plastic packaging to landfills. That is another agenda. Zero plastic packaging to landfill by 2030. Compostable plastic by 2025. And then minimizing plastic entering into the sea from the UK. That is again another aim. Whenever we are reducing the plastic waste leakage into the environment, then we can avoid plastic entering into the oceans. Comprehensive plan to reduce plastics leakaging from UK into the wider environment. From their country, they are reducing. Yeah. So whatever the mechanism they are following in the UK plastic pact is, first one is PRN, that I am going to discuss. Two mechanism they have followed. One is PRN, another one is PERN. These two are matrices used to define how much their aim they have achieved. So these are all the matrices used to calculate the level of attainment. Yeah. So PRN we can say as packaging recovery notes. So this is the certificates provided for each and every tons of packaging waste has been removed or reprocessed or exported. So PERN is how much recyclable plastic that is exported to other countries, how much recyclable plastic that is collected. So this is PRN and PERN. There is a difference that you can see in the next slide clearly. So it is an evidence or a certification of recovery or recycle. So it's a parts of responsibility. So it will help the UK to achieve recycling targets. Yeah. Here if you see one slide. Here this slide will clearly explain to you like how much polymer they are supplying manufacturers, and then it will reach the brand owners and then retailers, it will reach the consumer, it will reach the waste management scheme. But how much cleaned and decontaminated plastic will be collected by the UK government. So 1 ton of collected cleaned and decontaminated plastic will add 0.8 PRN value. You understand? 0.8 of PRN value. But how much tons of plastic recyclable plastic waste exported, that will add 1 PERN. So if I am having 100 tons of plastic waste, out of which I am using 50 tons of plastics, so I will get 50 into 0.8 PRN value, and 50% is 50 percent is exported, so I am getting how much 500 kg, so 0.5 PERN, so that's the value. This is the idea behind PRN reform. Companies producing should pay. So using the PRN and the PERN value, the UK government get sponsored by the government. Like companies producing difficult to recycle packaging material should pay the same as those producing easy to recycling packaging. So the money raised is not an investment; it's a strategic fund to improve recycling. So this system encourages the export of material, whereas a split target between the UK and the rest of the world could discourage this. Yeah, that's another thing. Here, if you see, UK recycling is 60%, 70%. That's the achievement. Their split recycling targets. So first year, 40% will be sent to rest of the world, and 60% they are recycling on their own. In by third year, they are trying to. I mean, not the third year. Which year their target is to reduce the export to the other rest of the world, and they try to recycle 100% of their own plastic waste in the packaging material. Yeah. So another company case study is Vinyl Plus. This is an European PVC company. As we mentioned, PVC is having least recyclable capacity. So they are trying to spend to over 100 million euros since its creation in the year 2000 has become the concrete example of voluntary commitment. 8 lakh tons of PVC recycling per year they are doing, and in 2016 5 lakh 70,000 tons of PVC was actually recycled in Europe, of which 1 lakh 20,000 tons were recycled in UK alone. Then this type of PVC U drain pipes, as you know, in the latrines we have PVC U drains, and soil pipes are available with core that contains at least 50% recyclable materials. That should be recycled, and the environment should ensure a more prudent use of natural resources. This is another case study for chemical recycling. As I mentioned, Plax is a trade name. So they are using this recycled chemical recycled plastic product as an industrial wax. So this turning plastic back into the crackers feedstock. So whatever the material we are getting after chemical recycling will not have own chemical composition of the feed. So whatever the product we are getting in this method is Plax, PLAXX, that is the industrial wax. So PLAX 50, 30, these are all grade, output grade that can be used as a raw material for crackers feedstock. Yeah. In another case study, they have a steam molding. Steam molding is, as we know, we have injection molding. So like that, whatever the recycled material, they did some injection molding by about 10%. It used a very small amount of water as a blowing agent injected into a modified nozzle during the molding process. So here comes the reduction in the water used for production of plastics, manufacturing of plastic. This is design alteration, design innovation, significant environmental benefits. Then again, here comes the case study of Currento cups. This is a coffee mug on-to-go cups, initially made up of different types of plastic having negative environmental impact. Now, 100% of this Currento cups are made up of recyclables and single polypropylene plastics, which you know PP is easily recyclable through injection molding if it's manufactured. Yeah. So another case study is in Ontario in US. Ontario is this is a strategy for waste-free Ontario, building the circular economy. They have some strategies. Waste-free Ontario Act came into enforcement by 2016, and they have two act enacted. One is Resource Recovery and Circular Economy Act of 2016. Another one is Waste Diversion Transition Act 2016. Both came into the new legislation, and the provision is moving towards the circular economy. So the major part is identifying the provisional interest, establishing full producer responsibility as we have discussed, and then establishing the resource productivity and recovery authority. Yeah. Then another another act, that is Waste Diversion Transition Act, will facilitate transition to new producer responsibility framework. So their vision and goals is to zero waste Ontario and zero greenhouse gas emission. Here in this diagram, if you see, by 2020 their aim is to, it was the act came in 2016. So their aim by 2020 is 30% diversion of waste into recyclables. Then 2030 by 50% diversion rate. Then in 2050, 80% recycle. By 2050 also, they are thinking like only 80% can be recyclable and 20% will reach landfill. So they know how much we can treat, and they are framing step-by-step approach. Yeah. So these are all the objectives and action plans of Ontario Vision. So enhance provisional direction and oversight, enable efficient and effective recovery system, create condition to support sustainable end markets. Again, it comes the market scheme. Increase waste reduction and resource productivity. Here we have the aim, objectives with the action plans. So we have 15 action plans for this zero GHG circular economy of Ontario. So these are all the timeline to achieve the targets. So you can go through the targets. It's again theory oriented. Enhance provisional direction and oversight. Enable efficient and effective resource recovery. Increase the waste reduction and improve resource productivity, and create conditions for sustainable end markets. And another one paper discusses about the this is the publication in Waste Management Journal of Elsevier, Circular Economy of Plastic Packaging in Austria. Yeah. So this is a material flow analysis. MFA is material flow analysis. This is simple. This also you can see in my paper, material flow analysis for landfill mining projects. So I have give you the link in the reading material thing. Whatever the 100% input should be in the 100% output, but how it plays in different sectors, that comes into the material flow analysis. So different here it's the divided by different types of product: PET bottles, hollow body large, film small, film large, like different types of plastics will enter into the waste management scheme, waste supply. out of which some of the plastic will be sorted, some of the plastic will be distributed, and again sorted plastic will enter into the material recycling and industrial incineration. Whatever distributed will go to waste to energy, and some are mechanically pre-treated, and least amount will enter into the landfill. The width of the line indicates the quantity of material, like 39 2, if you can see the difference in the width. So a limited amount will end up in the landfill. Plastics usually will be recyclable, so it won't reach the landfill. Yeah, I mean small quantity will reach the landfill. So by analyzing the material flow, we can identify where the leakage happens in the flow chain, that we can easily diagnose and we can work on it. So this is another material flow analysis for type of polymer, PET bottles, hollow bottles, and film smalls. This type of plastics, how it's end up in the different waste management scheme. Then comparison of collection, sorting, and recycling grades for different types of plastics. First one is light gray color will indicate the collected, blue will indicate the sorted, and dark will indicate the recycled. So which is like PET bottle, if you see 60% is collected, out of which 54% sorted, only 45% is recycled. So but PET bottle will have more percentage of recyclability. Yeah, that also one take away from this graph. Next to this will be film, large films, and then hollow bodies. These are all having more recyclable capacity, are happening in the country. Yeah. So this is again the same graph, how much collected, how much sorted, how much recycled, based on efficiency of collection. This is final treatment option. How much going to regranulated waste energy plant, how much going to incineration plant, how much going to landfills. So landfills will be the top green color, having low percent, like 2% or 1%. So most of the plastics will go to industrial incineration and waste to energy. So here also you can see PET bottles having 34, like sorry, other plastics will have more waste energy because that is not recyclable. Here PET bottles 45% regranulated. Regranulated means again made into monomers and made into the production line. That's called regranulation. Yeah. So on the conclusion, we can say like this achieves the proposed target of USA by both collection and sorting, input of the mechanical recycling process to keep material in the economy. To keep material in the economy, that's called a circular economy. We should not lose any material. We have to keep the material in the circular path. That is called keeping material circular economy. That will prevent loss. To accurately assess the performance, it is recommended that the target be calculated with respect to the actual output of the recycling process. Then the conclusion is necessary to assess the environmental performance, increasing targets beyond mass-based indicators respect to the environment. Only we should not assess the material flow. We should not assess only the cost benefit. We have to think about the environment point of view also. There comes the economic plus social plus environment, sustainable performance analysis. Then after all, a major objective of circular economy is to reduce the environment impact. Here comes the major objective. Major objective of circular economy is to reduce the environmental impact of production and consumption system. So the overall conclusion is to support the project and initiative, embrace the holistic approach, impact the wider system, think local as well as the global. Yeah. So collaborate with the innovatives, think long-term achievement of this recyclability. So this is all about the plastic recycling and circular economy concept for plastic waste management. Hope you are clear about this aspects. If you have any doubt, please post in the chat box. I am happy to answer, or else we will go to the assignment solving session. Hope you have no doubts. We'll move on to assignment solving session. Yeah, please post the answers in the chat box. The first question is, in the waste management hierarchy, which is the most preferred option? Recycling, reuse, source reduction, resource recovery. Yeah. I have a doubt about regarding about the exams. Question will be said by you or no. I am also writing the exam actually. I had the goal ticket. I'm just a part of teaching assistantship. Yeah.
So can we, excuse me, can we expect few questions from assignments and the questions you
uh,
are discussing here?
Yeah, actually, not from. This is also what this questions made by Brajesh Dubey sir in the last year and 2022. I have written two of his subjects. Most of the question will be from assignments only. So you can expect 60% from the assignment itself.
Okay, thank you very much.
So please go through the assignments. I think I have given one more hour. I have asked one more hour from NPTEL team. So we will discuss about this 8 weeks actual assignments of 2024 in that 1 hour. So you will get mail soon. So please join the session also for 1 week. Sorry, 1 hour to discuss this 2024's 8 weeks assignment. So I think the final exam will have most of the questions from that also. Yeah, so you will get mail. I don't know which time they have allotted, so please be check your mail and join the session. Thank you. I think the answer you have posted is C. Yeah, that's correct. Source reduction is the answer. Yes. So the most preferred option is source reduction and the least preferred will be landfill. If I am not try to reduce and then reuse and then try to recycle, then try to recover material and energy by incineration or waste energy, then landfilling will be the least option. Yeah, before 22, I don't know, sir. I think 23 or yeah, 23 I given, I guess. 23. No problem. It's the last night revision you can take. I will also read one, so you can take in the last night. Okay. This is the second question. Which of the following areas is Unilever working on to achieve its goal of moving towards a circular economy? Which are the following areas? Okay. Rethinking how to design their product. Following a linear approach of take, make and dispose. Exploring solution to price fluctuation in the material market. Both A and C. Sir, read the question again. Not D. Why Unilever should think about price fluctuation in the market? That's not the environment circular economy option, right? Yeah. So they can think about the price fluctuation, but that's not the circular economy. That's material flow part. Circular economy will think about the environment and waste disposal. So the option A is correct. Yeah, that's correct. Rethinking how to design their product. Second one is absolutely false because linear approach should not be there. Only circular approach should be there. So first A is correct. So here comes rethinking how they design their product. So which of the following statement is incorrect? In circular economy, the value of material is lost because they are discarded after being used once. In a circular economy, material constantly flow around a circular loop system. Circular economy means keeping the value of product in the economy without leaking into the natural environment. Circular economy is restorative and regenerative by design. Which are all the options are correct? Maybe more than one answer. Sorry, incorrect. Sorry, incorrect. Incorrect. Sorry, incorrect. Yeah. So the answer is A. Yes. So circular economy, the value of material will be enhanced, not lost. Yeah. So this means the material will flow around the loop. Correct. So moving on to fourth question, which is or are the technical strategy or strategies for the recovery and recycling of plastic solid waste, ensuring material applicability in manufacturing process. I am talking about the technical strategy. We have discussed the four strategies: technical, social, environmental, and market strategy. You have to think about only the technical strategies. Okay, ensure material applicability in manufacturing process, education of households or community on the relevance of informal waste collectors, formation of polymer recycling stream and markets, all the above. Maybe more than one answer. So technical strategy. Yeah, A correct, C is correct. Yeah, Sandamilam sir, I too thought initially A and C, but it's only A. Ensuring material applicability in manufacturing process. Why all the above? All the above are strategies, but not the technical strategies. Yeah, if possible, I will go to the PPT ones. Here you see, this is the environment strategy. I am about a increasing consumer awareness, educating the household community, and all social strategy. Technical strategy will discuss only about improvement in the recycling technology and infrastructure, improvement in size reduction, improvement in sorting technology, design of product, ensuring material applicability. I think this question was asked in this assignment also. You can go through. Okay. So the answer is A, only A. Okay. Then fifth question, which of the following is an example of a closed loop system? Virgin LDPE packaging material to littered. Virgin PET plastic bottle recycling. Virgin HDPE packaging bottle landfill. Virgin polypropylene single use packaging cover discarded in the trash can. They are asking about the closed loop system. Closed loop. Yeah. The answer is closed loop. B is correct. Virgin PET plastic bottle, then recycling. Others are disposal, only disposal option. Recycling is the last step. Means, sir, can you please elaborate your question? The recycling is not the last step. Recycling will again, it will again circulate to virgin PET for closed loop. No, closed loop don't have any last step. First, last will be only in the linear economy or linear approach. In circular loop system,
So can you say there is no disposal in case of closed loop system?
yeah, that's correct. There is no disposal in the closed loop system.
Yes, as littered, landfill, and discarded in trash can, they are disposal options.
And
So we
landfill
should not
also.
go for those options.
Uh,
Yes, landfill, discarded, and littered. All
all
those
are
are related to
linear
disposal.
approach. But recycling will again close the loop
Yes,
by entering the, I mean, shifting the plastic bottle into the manufacture line. Yes.
yes, yes.
Hope the Gupta sir, you have got the answer. I will go to the next question. Yeah, this is what we have discussed. The sixth question, which of the following is a consortium of approximately 60 European companies, organizations and associations across the entire value chain of flexible packaging? Plastic Europe, CFlex, European Plastic Distributors Association, அப்புறம் APME, Association of Plastic Manufacturers in Europe. Yeah. Right. Correct. CFlex. Circular economy, flexible packaging. Yeah, correct. That's the initiative by the consortium of 60 European companies, organization and association. Yeah. Seventh question. According to the British Plastic Federation, what is the recycling rate of cartons? So we have discussed about this recycling percentage of different plastics, plastic containers. So 27%, 47, 37, 70 for cartons. So for plastics, we have seen about 74, and glass and other materials about 70, and for cottons, we have discussed like a minimum of, yeah, 37. That's correct. Not 70, sir. 70 is for glass, aluminum, and steel. 74 is for plastics, and for curtains, multi-layered plastic, as I mentioned, only less. Curtains is like the tetra packs, fruity pack, 10 rupee fruity pack, or 10 rupees, this type of things are coming. Amul milkshakes, Kavin's milkshake, that and all cartons we can see. 37%. Which of the following target does Ontario set an interim goal to mark their progress and keep on track with their strategy to achieve a circular economy? 25% diversion by 2020, 30% diversion by 2025, 50% diversion by 2040, and 80% diversion by 2050. This is again their goal. Yeah, 80% diversion by 2050 is correct. Here you can see in this diagram 30% diversion by 2020, 50% diversion by 2030, and 80% diversion by 2050 is their target. This is based on Ontario Zero Waste Act 2016. Yeah. So question number 9. Select the significant objectives of new plastic economy of Europe. Educate, innovate, circulate, eliminate. You can uh, you can take all the significant objectives, more than one option. Mm, Ramji sir, you can take more than one option. Yeah. Not ABC, not ABC. It's B, C, and D. Yeah. Innovate, eliminate, innovate, and circulate. That's what we have discussed in the before 15 minutes. Like new plastic economy will have these three targets: eliminate, innovate, and circulate. Eliminating unnecessary plastic packaging. Innovating recyclable plastics, 100% recyclable plastic. Circulate this recyclable material into the production line or new packaging product. Yeah. So 10th question, which of the following is the objective of packaging recovery notes, PRN, packaging recovery notes. Another one is PERN, packaging export recovery notes. So this is what is the objectives. So this gives reward are given to the consumers for compiling the waste management rules, or it is a certification of evidence of packaging waste recovered, reprocessed or exported. It's a barcode sticker attached to the product to identify each type of plastic. And it's a plastic notes recovered from the waste recycling cycle. What PRN denotes, or what is its subjective? It's easy. Hello, am I audible? Hello, I'm not getting any results. Yeah, okay, sorry. I thought I was disconnected. So easy. The PRN is the certificate, as I mentioned. It's a certificate of evidence of packaging waste recovered, reprocessed, and exported. Yeah, hope you are not clear about PRN. I can explain here also. So PRN is this is based on UK uh, part scheme, plastic part. So this PRN will help the UK achieve recycling targets. Yeah. So this is simply a certificate of evidence that proves that ton of packaging waste has been recovered or reprocessed. Yeah. Question 11. The Waste Free Ontario Act 2016 introduced extended producer responsibility, in which producers are also responsible for waste management. It's true or false? Waste Free Ontario Act 2016 introduced EPR, in which producers are also responsible for waste management. Yeah, it's true. It's true. So they have established a framework for EPR. 12th question. Select all the correct statements from the following. All the correct statements. Okay. So circular economy is a restorative and regenerative by design. In circular economy, material always flow around an open loop system. In circular economy means keeping the value of product in the economy without leaking into the natural environment. In circular economy, the value of the material is not lost because they are not discarded after being used once. All the above, or what happened to B? Okay, okay. A, C, D. Is it correct? Except B. Yeah, it's correct. A, C, D. Perfect. 13th question. The plastic circular economy delivers a more competitive economy and drives greater resource productivity. As I mentioned, plastics having uh, more possibility to reintroduce in the circular economy and drives greater resource productivity. True or false? It's true. Fine. So why is circular economy important? Uh, here comes the, where is it? I think I have given a wrong slide for this. Okay, no problem. So plastics are key enablers of, this is a true or false question. Plastics are key enablers of circular economy, directly facilitating the circularity of product and improving resource efficiency and sustainability along the value chain. It's true or false? Kindly read once. Plastics are key enablers of circular economy, directly facilitating the circularity of product and improving resource efficiency and sustainability along the value chain. Yes, it's true. This is the first line of plastic circular economy. 15th, which of the following is or are technical matrices used for resource recovery? Reusability, technical matrices. We have discussed in more technical matrices. Reusability, biodegradability, education, mass and technical recyclability. A and D. A, B, D. Is B, biodegradability and technical metrics for recovery, resource recovery. Technical metrics. Okay, we will check on the slide. Reusability and the mass and technical recyclability is correct. Yeah, here. These are all plastic circular economy key enablers for like these are all not matrices. These are the matrices. Technical biodegradability is a it is a positive impact on the circular economy by plastics. But comparing to technical matrices, reusability, remanufacturability, mass recyclability, technical recyclability. Then we have discussed about recoverability. These are all the matrices for resource recovery. Yeah. Again, 2020's assignments, most of this will be repeated. I will just go through. In waste management hierarchy, which is the most preferred option? Source reduction, yes. Which of the following areas in Unilever working on to achieve its goal on moving towards the circular economy? Rethinking how to design their product. Yeah. Which of the following statement is incorrect? In circular economy, the value of material is lost. That is wrong. Yeah, this we have discussed earlier. So, which are the technical strategies for recovery and recycling of plastic solid waste? Ensuring material applicability in manufacturing process, education of household or community on the relevance of informal waste sectors, formation of polymer recycling. This is technical as well. First one is correct. Yeah. Importance of circular economy. This you can answer actually. Importance of circular economy. Position the world to better address emerging resource security or scarcity issue in the future. Help reduce the environmental impact of our production and consumption in the world. Reduce waste. All the above. Yeah, yeah, it's a simple question. Duvesa's question will be simpler only. So don't worry for the exams. You can easily score. And I hope you have given for 8 weeks actually best of 6 assignments will be taken. I go hope everybody have given best of 6 assignments. Yes. If you are not given any assignment also no problem. 0 mark will be no. Some percentage is there for assignments. I will go through the NPTEL course guidelines. So this is again 60 European companies consortium will be Ciplex. Yeah. So according to British Plastic Federation, this you can answer. What is the recycling rate of consumer plastic drinking bottles? 27, 47, 74, 70. British Plastic Federation report. What is the recycling rate of consumer plastic drinking bottle? Yeah, it's 74. 70% of consumer plastic bottle drinking bottles recycled. 70% of glass, aluminum, steel drinking cans are recycled. 37% cartons are recycled. Yeah. Here, as per the goal set by Ontario, 80% diversion by 2015 we have seen. Okay, this you can answer. Waste Free Ontario 2016 enacts which are the following acts? The Resource Recovery and Circular Economy Act 2016, Canadian Environment Protection Act 2016, Waste Diversion Transition Act 2016. This question was asked in this assignment also, I guess. 1 and 2, 1 and 3. Yeah, 1 and 3 is correct. Okay. So those are the two enacted acts along with the Waste Free Ontario Act 2016. Okay, this you know, PRN is the certificate of evidence of packaging waste recovered and reprocessed or exported. Exported in the sense PRN. Yeah, both are again a matrices to evaluate the target achieved set by UK government. So, and this question I answered now only. The packaging recovery node system (PRN node system) was designed to help the UK achieve recycling targets set by the government. Yeah, it's true. The goal to achieve circular economy in Ontario is to attain zero waste Ontario and zero greenhouse gas emission from the waste sector. True or false? The goal to achieve circular economy in Ontario is to attain zero waste Ontario and zero greenhouse gas emission from the waste sector. Yeah. Why it's false? Why? Why everybody is answering B? Can you please explain in the chat box? Okay. You are confused with the greenhouse gas emission. It's actually true. Here you can see I have read this, I guess. The goal of zero waste Ontario is to achieve zero waste Ontario and zero greenhouse gas emission from the waste sector, because they are reducing the they are diverting the waste from reaching the landfill. So they are cutting off the greenhouse gas emission also. Yeah. So both are the goals of Ontario waste, zero waste. And this, you know, plastic circular economy delivers a more competitive economy and drives greater resource productivity. This you can answer. Plastics have a negative impact on a range of circularity levers across product life cycle, including material efficiency, energy efficiency, CO2 reduction, recyclability, durability, biodegradability. A and B. I mean, true or false? Ah, read the question. Waste having a negative impact. Yeah, it's a positive impact. Like, but the ranges are correct. Like material efficiency, energy efficiency, CO2 reduction, these are all correct. So yeah, the answer is actually it's a positive impact on the wide range of circularity. These are circularity levers. Yeah. So the last question: to ensure landfills are well planned and managed to minimize their need to reduce greenhouse gas emission, is an action proposed towards waste-free Ontario. True or false? Why B? To ensure landfills are well planned and managed to minimize their need to reduce greenhouse gas emission is an action proposed towards. Yeah, this I have skipped. Answer is true. These are all the action plans I have mentioned, 15 action plans. In that you can see the seventh action plan, ensure landfills. Here you can see seventh action plan. In the enable efficient and efficient recovery system, ensure landfills are well planned and managed to minimize their need and reduce greenhouse gas emission. Because as I mentioned, the zero greenhouse gas emission, zero waste circular economy of Ontario will have zero greenhouse gas emission means zero landfills or lesser landfills, waste going to landfill, diversion, more diversion. Again, this is the concept of Ontario zero waste. Yeah. Thank you so much for joining. I hope today we have 13 participants up to the end. So thank you so much for joining all the 8 sessions. So today is the last session, I guess. If I get one more session, we will discuss about this 8 weeks assignments of 2024 session. So if you have any doubt, please write me on saravanan899 at gmail.com, or you can call me in WhatsApp anytime. Please write some comments for me. If you have any positive or negative comments, please write to me, or in the NPTEL Google form you can also write. I am happy to get your comments. Thank you so much for joining. 2024 assignments are enough to get 80. that that I don't know. I am not taking the questions. I am also writing the exam. That I don't know. Sorry. All the best for your exams. Thank you so much. I hope I have done my best for you for teaching these assignments. Yeah. Thank you, Gupta. It will be easy. It will be easy, very easy. I think, yeah, NPTEL plastic waste management is computer based exam only, so no problem. Yeah. Thank you so much. If you have any doubt, please post in the chat box, or you can write me at any time. You can call me, no problem. Next class, I don't know. This is the final class as per the schedule. I have asked for one more class. You will get the schedule through mail. Please join. Thank you. If you don't have any question, you can leave the meet. Exam is in afternoon now. Admit card, I don't know, but you got the exam date and the exam center. You can check with the NPTEL website. It be difficult for morning. I don't know. Now only I came to know there is an afternoon session. I don't know. Thank you so much for joining. I'll close the meet. Thank you. Yeah, thank you so much for the quote. It means a lot to me. Thank you. I'll end the meet.